let's take a look at how you might have solved the volume problem. In this problem, your task was to take an audio file and modify its volume by a particular factor, increasing or decreasing the volume of the audio file. So let's now take a look at the solution inside of volume.c. We gave you some of the initial code inside of the main function already, but the first thing you needed to do was to deal with the header, to be able to read the header from the input file and to write that header to the output file. The first thing you might have needed to do was to create some place in your computer's memory into which to read that header. And so the first thing we have here is the declaration of an array called header. Its type is uint8t, a type for unsigned 8-bit integers, just representing bytes. And how many bytes do we want in the header? Well, we want header size bytes. Recall that header size is a constant integer, just equal to 44. That's the number of bytes in the header of a WAV file. So we could have written header 44 here, but it's slightly better designed to take advantage of this constant rather than reuse the number over and over by just saying header size. So we now have this buffer, as we might call it, to represent the header. And now we need to read that buffer from the input file. And so here, we're reading header size bytes from the input file, and we're going to go ahead and read it into the header variable that we've created here. And after we've read it into memory, then we can write that same data to the output file, calling the fwrite function, and then writing the contents of that header to the output file. And how many bytes are we going to write? Well, we're going to write header size bytes. Those lines are going to have the effect of reading 44 bytes from the input file and then copying them into the first 44 bytes of the output file. Next, after the header of an input file, is going to come all of the bytes of data, the sample bytes that are contained within the audio file as well. And for each of those 2-byte samples, we want to read that sample into memory, modify it to adjust its volume, and then write it to the updated file. So here, we're going to start by creating another buffer. This time, the buffer doesn't need to store 44 bytes of data. It just needs to store enough data for a 2-byte sample. And for that, we can use the int16t type for a type that stores an integer with 16 bits. And now, we're going to repeat this inside of a loop. We're going to use the fread function to read from the input file into the buffer, passing in the address of the buffer so that fread knows where to put the memory that it's reading. And we're going to read one sample of 16 bits, in other words, 2 bytes. And because this is in a loop, the effect this loop is going to have is it's going to repeatedly read a sample, one sample after another, until we reach the end of the file. Fread returns to us the number of blocks of data it was able to read successfully. And so once it's no longer able to read any more data from the file, fread will return 0. And at that point, while is going to treat that as false and will exit the loop. So now we've read the sample into memory as this variable buffer. And now we need to update the buffer by multiplying it by factor. If factor is 2, that has the effect of doubling the volume. If factor is less than 1, it has the effect of decreasing the volume. So factor could be some other floating point number to change the value of this particular sample. And once we've changed the value of the sample, now we just need to write that updated data to the output file. Again, using fwrite to do so, writing data from the buffer to the output file. And how much data are we writing? Well, it's however big an int16t is, which in this case is going to be 2 bytes. After that, we wrote the code to close the files for you already. So now when you run this program, you should be able to specify an input audio file, specify a new file name for an output audio file, as well as a factor by which to change that volume. And you should be able to generate new audio files that have the same audio, but just with a different volume compared to the original. My name is Brian, and this was Volume.